Okay, this is exercise number 7 from the book. A couple of formulas involving points in the plane. So part A was to plot these 2 points, 2, 2 and 4, 14. So I did that already. Now notice when I drew the XY plane, this Cartesian plane, I only drew the portion of the axes I'm going to need. I didn't put any detail down in the lower left region because I'm not plotting anything over there. And that's always fine. Okay, so we plot these 2 points. Part B of the problem asks us to find the distance between them. Now when you think about points and what they're useful for, I mean they're useful for locating things like, say, on a map, and of course that might be an interesting question to find the distance, the number of units between these 2 points. Okay, so there's a formula for that. It's called the distance formula. And in the book it says distance d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So basically we have to subtract the x-coordinates of the points, square that, subtract the y-coordinates, square that, add those 2 results together, and take the square root. Okay, so I'm going to start putting the numbers in here. x2 minus x1. Well, if this is my second point and this is my first, I'll take the second x-coordinate, which is 4, and subtract the first x-coordinate, which is 2, and square that. Okay. And then to that I will take the difference of the y-coordinates. So 14, that's my second y-coordinate, minus the first y-coordinate, which is 2, square that. Okay, and the whole thing is under the square root sign. Well, this is the square root of 2 squared plus 12 squared, which is the square root of, I believe, 148. Okay, so that's the answer. Whatever that number is, that's the distance between these 2 points. And we can't probably picture this actual number, but we can simplify it if we wanted an exact answer. I think 4 factors out of 148, so we can write this as 2 times the square root of 37. But what's probably a little bit more helpful to do in a problem like this is to actually get a decimal number here. I mean, this isn't a perfect square. This doesn't really tell us what the number is. If we go to the calculator and compute the square root of 148, yeah, we get something that's a little bit more easy to digest. We get that it's about 12.17. Okay, what does that mean? Well, it means there's about 12 units of space, each unit being a tick mark on my graph here. About 12 units, just a little bit more, between these 2 points. Okay, not something you can easily get exactly just by looking at the graph. Okay. Now, part C of this problem asks us to find the midpoint of these 2 points. Again, it means probably just what you think. There's, if you give me 2 points in the plane, there's some point directly between them, right in the middle. Okay. Well, it's going to be somewhere around here, but there's a formula for it. The midpoint is, again, it's just another ordered pair. It's not a number like distance, it's just an ordered pair. And to get this, we use the midpoint formula, which says take the 2 original points, add their x-coordinates together and divide by 2. Okay, that's the x-coordinate of the midpoint. And then add the y-coordinates together and divide by 2, and that will give you the y-coordinate of the midpoint. Okay, so for the points that we have, let's see, I add the x-coordinates together. Okay, that's 2 plus 4 over 2. Add the y-coordinates together, that's 2 plus 14 over 2. And I can probably go ahead and simplify it. The x-coordinate is going to be 6 over 2, which is 3. The y-coordinate is going to be 16 over 2, which is 8. Okay, so that means the point 3, 8, let's see, right about here is the midpoint of these 2 points. And it looks pretty good on the graph, so confident that we did everything okay.